As we get into 3D shapes, I thought it might be practical to use some 3D software to give you an idea of what takes place when an object is cut by a plane. The advantage to this software is it's actually going to utilize a plane cutting through these three-dimensional shapes, and you'll be able to see the cross-section within that particular shape. And there's probably a good chance that you have similar 3D software, as 3D printers are becoming more common, already installed on a Windows 10 computer, so you might be able to play with some of these yourselves at home, but I thought I would go ahead and introduce you to them now. Our first image is a square pyramid, and you'll notice it being a square pyramid by looking at the bottom and realizing that it is a square, and all four vertices of the square come up to a single vertex point at the top of the pyramid. Now let me introduce the horizontal plane. And when I have a horizontal plane on this pyramid, you'll see the bisect cut within that pyramid has essentially cut off the top of the pyramid so that we can see the product of the cut. And the product of the cut when we do a horizontal cut is going to be a square. Then as I transition or angle that cut, we notice that we no longer have a square, but rather we have a trapezoid shape forming. The more I turn it and angle it, the more that trapezoid changes. Then when I get to having a perfect vertical cut straight down through my pyramid, you'll notice now the shape of the cut ends up becoming a triangle. One of the things we'll eventually recognize is that the number of sides of a cross-section is going to be dependent upon the number of sides of the original 3D shape. Now this particular 3D shape, being a square pyramid, has the four triangular sides that form the pyramid, but it also has the one side that is the base. So the maximum number of sides in any cross-section cut would be 5. So now looking at the screen here, you can see one cross-section cut that visualizes the maximum number of cross-sections. Along the bottom we have 1, 2 up both sides, and then 2 that come to a point. So we have 5 sides on this particular cross-section, and as I move it around and rotate it, you'll continue to see that the 5 sides can change in their dimensions, but still we have a maximum number of 5 sides to a cross-section of a shape that has 5 surfaces. That'll be important for you to remember because you'll probably see that again in the study guide and probably even the test. The maximum number of sides that a cross-section can have is dependent upon the maximum number of sides of the original shape. So if the original shape had 5 sides, the maximum number of sides for a cross-section would be 5. If your original shape was, say, a cube has 6 sides, then the maximum number of sides that that particular cross-section could have would be 6. So again, just giving you a little bit more of a visual of how the cross-section changes depending upon the orientation of the diagonal cut. Now we'll transition into our next shape. And here we have a cylinder. So again, we're going to do a horizontal cut on the cylinder. You'll notice that a horizontal cut on the cylinder simply produces the circle within the shape. The shaded area up above the top represents the remainder of the shape prior to being cut by this plane. And so now I'll begin to angle the cut. And as I angle the cut, you'll notice a slight variation in the shape of the circle. The steeper the angle, the more that circle becomes what we actually classify as an ellipse. I would suffice to take it a oval as a solution as well. When we come to finally having a vertical cut, you'll notice that the cross section forms the shape of a rectangle. And this would also be dependent on the shape of your cylinder. If your cylinder is even in height with its diameter, then that cross-section wouldn't be a rectangle, but rather it would be a square. Either way, you should be able to figure out a close representation of what the cross-section would resemble, four-sided figure. Again, back to a horizontal cross-section, shows that it is a circle, the shape of the base of the cylinder. Next, we transition into a cone. We'll start with that horizontal cross-section. That's going to show you that if you chop off the top of a cone, you end up with a circle. And so depending on the position of that plane as it is cutting off the cone, you'll end up with a different diameter for the circle. Now I'll start to show you what happens as we tilt that cut. Again, the steeper the cut, the more the circle turns into an ellipse. And the cone has a unique feature in that as you form your cross-section across the base actually turns you into more of a parabola shape. And then eventually when you get to having a straight vertical cut, all you see if you cut straight from the top is the triangle shape. So it's really, you have to be careful and visualize in your head where is the cut taking place and what are the possible arrangements that that cut could do to the particular shape you're dealing with. Now I'm showing the plane as it moves from the side to side vertically to the cone, and you'll notice that it forms a variation of parabolas depending on where it is in relationship to the cone. In the center of the cone will be the only spot that it will form a perfect triangle. Anywhere else, it will form a parabola or potentially an oval depending on, or a ellipse depending on its position. Now we transition over into a rectangle. Make this rectangle a little bit bigger so that we can apply some cross sections and you'll actually be able to see how the shapes or how the cross section creates different shapes. And one of the things I want you to recall again is that maximum number of sides on this shape. This shape being a rectangle should have a maximum number of sides of 6. And have a front and a back, a left and a right, and a top and a bottom. And remember that we said the maximum number of sides of the original shape will impact the maximum number of sides on any cross section. So if I have a shape with 6 sides, then the maximum number of sides for a particular cross section will be 6. So eventually we'll get to a point where I will show you the 6 sides of that particular cross section. Notice as we tilt and angle this cross section, we can see that the cross section of the shape would form a rectangle here. Now when I tip it down long ways, you'll see the rectangular shape will shrink and grow depending on the angle and depth of the cross-section cut. And now I'm starting to turn the orientation and you'll start to see the 6 sides of the cross-section. It almost looks kind of like a I don't know what shape you'd call that. But you could see the 6 sides of that particular cross section. And then again, as I change the orientation of the cut, it changes the shape of the cross section. But at no point will any of the cross section sides exceed a 6-sided shape. Hopefully that gave you a clearer view or understanding of what takes place with cross sections and various shapes. And depending on what shape you're dealing with, there's a whole litany of different possibilities of cross sections. It truly takes visualizing what's taking place with a particular shape and having some sense of what are the bases of the shape you're dealing with. When you're dealing with a cylinder, naturally its base is a circle, which means that if you take a vertical cross section of it, you will end up with a rectangle. If you take a horizontal cross section of it, you're going to get a picture of its base. The same with a square pyramid. When you take a horizontal cross section of a square pyramid, your cross section will be the shape of its base. Same with a triangular pyramid. When you take a horizontal cross section of a triangular pyramid, your cross section will be the shape of the base. Hopefully this helps you to have a better understanding of cross sections.